All right, hello everyone. My name is David Cheng, and I'd like to welcome you all to ARC 229. In this session, we're going to be sharing some of the best practices and learnings for how large enterprise customers can manage large fleets of VM on Google Cloud. All right, before I get started, I do want to introduce a few of my fellow co-speakers. We have Omkar Suram, who's a product manager on Google Cloud. We're also joined by Milo Harris, a principal system architect at CoreLogic, and Mohammad Alhareri, who's a cloud architect at ATB. All right, so we're going to get into it. As many of you may know, managing large fleets of VMs can be challenging. Very likely, many parts of your team are on different parts of the modernization journey. Some may have fully shifted left and embraced the IAC movement, whereas others, and rightfully so, may still be managing VM by VM. All right, there's a lot of complexity and a lot of tension between where your teams might be. There's also a challenge where you're trying to move fast, enable your teams to innovate and have agility, while you're still trying to enforce the right guardrails and controls for your organization. And lastly, on top of that, there's multi-dimensional complexity. You might be managing against cost, performance, reliability, security. So managing all of this can be particularly challenging. But thankfully, we have you covered. So in this session, we're going to go through a few ways and talk about hopefully some data points for you to take away on how you can better manage your large fleets of VMs on Google Cloud. So what we'll do is Omkar's going to start off, and he's going to share some of the new tools that we've been working on to help customers, no matter where you are in your journey, if you're fully shifted left or still managing VM by VM, how you can better manage and govern your deployments. Milo's going to walk through this journey that CoreLogic has been taking as they've moved over 100 applications onto Google Cloud, and how they've been able to manage and govern and automate their deployments. And then lastly, Mo is going to talk through how ATB Financial has been able to successfully go through a crawl, walk, run motion to get to modernized management on Google Cloud. So with that being said, I'm going to hand it over to Omkar.
Hi, everyone. Thank you, David. Good afternoon. Hope everyone is enjoying the conference. I'm Omkar. I'm the product manager at Google. I'm excited to talk about day two management on Google Compute Engine. At Google Cloud, our goal is to meet customers where they are in their journey and accelerate their path to value. To expand on what David mentioned, we understand that each workload has its own unique requirements. More complex the workload, more steps are involved to optimize and make sure you're maximizing the value. To simplify, breaking down your workload and these activities into design, deploy, govern, and optimize categories helps you gauge how you want to manage your compute workloads. With the right strategy, you can easily address the operational overhead of managing some of these day-to tasks that can significantly cause toil by solving them in design and deploy phase. In compute-specific context, many shift-left activities that David alluded to, like building secured golden images, creating your own landing zone for like new workloads, can help you solve the overall day-to governance strategy. It's an ongoing process. Discovering optimization opportunities and redesigning your system will take you a long way. Thankfully, Google has covered. You have many products and services that will allow you to do this complex activities with ease. Today, we will get to hear from Milo and Mohammad how they have automated some of these tasks like image management, blueprint automation, etc., to optimize their workload on Google Cloud. I will double-click on the workload manager and VM manager to help you efficiently operate your compute workloads. To expand on the previous slide, I want to highlight Architecture Center, a one-stop solution for best practices and guidance need. You can find detailed architecture guides, frameworks, blueprints that you can further customize based on your needs, and it can significantly help you improve your deployment velocity. Specifically, the architecture framework covers many such best practices that across Google Cloud products and features that will help you create secured, reliable, and performant architectures. We hear from our many customers that, well, the theory is amazing. How do you put this into practice? I want to highlight Workload Manager, a purpose-built product that allows you to continuously validate your specialized workloads like SAP and SQL Server against best practices. These best practices are built by Google SMEs that help you improve your reliability, security, and performance of your workload. Now with Workload Manager, you have insights to help take actionable insights to help you optimize these mission-critical workloads. But you might be asking, what about the other best practices? I'm excited to announce the public preview of custom rules in Workload Manager. You can write your own policies and customize them based on your organizational needs. Google loves open source. Custom Rule offers a fully managed OPA engine that allows you to write Rego-based policies. During this preview, you can write policies against the cloud asset inventory, as well as few metrics from cloud monitoring. Remember, we spoke about best practices in architecture framework? Now you can automate those best practices based on your needs to flexibly and consistently validate thousands of resources across your Google Cloud deployment with super ease. With custom rules, now you can decouple and empower your specialized teams like security, FinOps, Ops, support, etc., to build and manage their own best practices, including config troubleshooting across your organization. In addition to the UI, all those findings can be unified into the same BigQuery dataset that allows you to easily integrate with your existing reporting system, or you can create Looker-based dashboards to manage these findings centrally. Another thing, which is managing VM guest environment, can get quite complex when you're running large-scale VM fleets. There can be significant toil associated with the guest OS management if not done correctly. With VM Manager, you can easily discover OS packages across your thousands of VMs at scale across your entire organization. With VM Manager OS inventory, you can quickly detect vulnerability exposure installed on your packages on your VMs. This detailed CVE information is available to you via Cloud Asset Inventory or Security Command Center. You can also export or schedule export these findings to your own BigQuery dataset. This allows you to easily integrate with your existing reporting system and simplify the task of vulnerability finding, which is a critical activity for many organizations that are running large-scale compute workloads. Now that you're able to understand the security exposure across your VMs with ease, VM Manager also allows you to do a patch job across your VM fleets. Or you can update all the packages, or you can specify packages that you want to update. With VM Manager Patch, you can schedule regular patch jobs, as well as control advanced config to ensure your VMs are running the most up-to-date packages. To take a step further, VM Manager also offers OS policy. You can write custom policy to validate if a certain configuration or a package is properly installed on your VM guest environment, or you can write an additional enforcement step to rectify the issue itself. We are also excited to announce the cross-project dashboard that allows you to view OS policy compliance as well as the patch job across multiple projects in a single console. Now let's hear it from our customers, Milo and Mohammad, how they have perfected managing compute workloads on Google Cloud. Over to you, Milo.
All right. Thank you, David and Omkar, for having me today. My name is Milo Harris. I'm with CoreLogic. I'm a systems architect, and I'm here to talk to you today about how we manage our systems that we migrated from on-prem data centers to GCP. But first, a little bit about CoreLogic. We're an information services provider which adds value across the property landscape. We do this by offering data, tools, and services to help agents, lenders, carriers, and innovators better service their clients. As you can imagine, being a data company working within the property landscape, there's a lot of applications and services to manage. Our 5-plus-year journey to GCP involved over 10,000 servers, hosting hundreds of applications, and involved dozens of teams, each with varying degrees of cloud readiness. We knew from day one that managing such a large ecosystem was not going to be trivial. Our goal was to not only reduce costs, but also improve resiliency and reliability of our platforms. It became apparent that merely doing a lift and shift would only bring with it years of tech debt, along with the negative implications of high GCP costs, not so great security, and maybe average performance. To ensure success, it became clear that we needed an established cloud operating model, or COM, which would define our entire transition philosophy. Our COM covered all aspects of the migration, ranging from how applications would be assessed and blueprinted to how teams would gain access to their systems once the migration was complete. But one principle spanned the entire COM, and that is automation. Clearly, there's a lot we could talk about here. Today, however, I'm going to talk about two key things. One is how we standardize deployments through infrastructure as code, and then how we improve security and resilience through repaving. And I'll touch a little bit on how we govern those areas. Through our COM process, we determined that we couldn't properly support an ecosystem that didn't have tight guardrails in place around how instances were provisioned. With that in mind, we mandated that all of our infrastructure across GCP must be built through code. This includes everything from compute instances to the network, and we leverage Terraform for the GCP components and Ansible for the application stack. To ensure teams across CoreLogic all used a similar pattern for their projects, we deployed shared Terraform modules. These were based mainly on the Google-provided templates, and then we customized them for our needs. All of this is driven through standardized CI/CD pipelines in Jenkins, and they're built for each application as part of the initial onboarding process. By enforcing a strict infrastructure as code model, we've ensured that all code and server deployments work essentially the same way. And this helped eliminate unique deployments. To do this, we had to walk a tightrope by focusing on what really mattered in building these structures, while still allowing our end users or teams to customize as necessary. Since we're ensuring that all compute deployments are fully automated, it seemed logical that we also improve security as part of this process. And a major pain point has always been around OS patching. To solve this, we went with a repave model, as opposed to a typical patch in place. Now, for those of you who may not know what a repave is, I'm referring to the practice of periodically rebuilding your entire server from scratch, fully automated, using the latest operating system at that point in time. By doing this, we eliminate the task of OS patching from the support teams. They can just focus on supporting their applications and not worry about that security aspect. Plus, there's an added benefit that we know every system is rebuildable at any point in time. While the vast majority of our systems follow this repave, there are always exceptions, and exceptions can't be avoided. There may be applications that cannot be repaved due to licensing reasons or the age of the application, what have you. And in those cases, we rely on GCP's VM manager to take care of the patch management, and it's been working great. To ensure our GCP projects only used approved OS images, we established an image factory dedicated to producing our CoreLogic Golden images. Our image factory is both a team and a service stack built on cloud functions with PubSub and leveraging the GCP Python SDK. And they focus on crafting these OS images using Google's official GCE public images. We count on Google's Windows and Linux images for their regular release cycles and assured compatibility within GCP. Since those images come pre-tuned and tested by Google, we can focus on our specific customizations. By locking down projects so compute instances can only pull our golden images, we can be sure that all systems deployed meet our minimum security and compliance requirements. Further, by pairing compute metadata, such as the specific golden image used, along with the compute labels that we define through our infrastructure as code, we can feed all of that into BigQuery and through Looker, report out on security compliance. I've only briefly touched on our journey to GCP, but the key takeaway here is that with careful planning and a clear vision of goals, along with Google Cloud's standardized and well-integrated APIs, utilities, and images, CoreLogic was able to significantly reduce costs, standardize deployments, and improve reliability across our entire technology stack. Thank you.
Thank you. Thank you, Milo, for your insight. Hi, everyone. I'm glad to be here with you today. My name is Mohammad Alhareri. I've been with ATB for the last 14 years. My current role at ATB is to help my teammates achieve their cloud goals as a cloud architect. I'm very proud to share with you some of what had helped us on our GCP journey at ATB Financial. But first, a little bit about ATB Financial. We are ATB Financial. We are based out of Alberta, Canada. We are 5,000 team members strong, proudly serving more than 800,000 customers across several products, such as ATB Personal, ATB Business, ATB Wealth Management, and ATB Capital Market. All of these products require sometimes their own solutions and their own unique requirements. On the technical side of ATB Financial, we run a large hybrid environment. Some systems are on-prem, some systems are on our private cloud. We have several SaaS offerings, and of course, GCP is our cloud provider. On GCP, we have several cloud solutions, or we use several cloud solutions such as BigQuery and Apigee, and we have several hosted applications on VM and Kubernetes. I was part of ATB's first SAP migration to GCP back in 2018, but since then I've been more focused and more involved with the cloud aspect of our GCP environment. Our GCP environment, as I said, is quite big. We are about 550 compute engines, 400 JKA cluster. So having such a large environment means we have different teams working on different applications with different levels of adapting to cloud practices. But to be fair to all, it mostly depends whether the application was a fresh install into GCP with a fresh, clean slate of designing new processes, or a migrated application, which means dealing with legacy processes and downstream impact to deal with. But when reflecting on my work with several projects and several teams at ATB Financial, I noticed a crawl, walk, run pattern. In the crawling stage, this would be where we use spot instances instead of using dedicated VMs, which with large CPU and memory requirements can be expensive. So sometimes choosing a spot instance instead of for these applications can be good enough for a POC or a less critical application, which can be good enough for that. Another example would be creating firewall rules that are tag-based to protect our GCP assets. Again, these steps are in the right direction, but they are still in the crawling state because we are using the GCP tools, but we are still crawling. For our walking stage would be when we started investing time in automating the deployments of our assets, whether using GCP-provided tools or using Google Client scripts or other third-party tools such as Terraform. which made our builds more consistent and much easier to operate. So for our future deployments and enhancements, it became an adjustment to a script rather than manually modifying and tens, maybe hundreds of artifacts manually. And now, a lot of our teams are really running because these teams are CI/CD now integrated, and all of their infrastructure is deployed as code. They are leveraging all the features that make sure our infrastructure, our code, is validated, approved with audit trails, and its lifecycle management is automated and managed by our scripts and GCP tools. No manual manipulation. Looking now at where we are on our GCP journey, I believe that now a lot of our teams and processes at ATB Financial are running, and some are even sprinting. To name a couple of our teams, I would say the Cloud Native Platform Operations, CNPO, and our security teams, whether it is an infrastructure security or app security team. They're leading the charge for us. I don't think we have any more teams that are crawling, but some of us truly started from the crawling stage. Second items that helped us on our journey was we evaluated our processes and saw what can be improved. So depending on where you're coming from, in our case, we came from an AIX, a Power Server environment. A lot of our processes were designed and created with the on-prem Power Server's abilities at the time. Now that we are on GCP, we are seeing that these legacy processes, whether technical or business, are limiting our abilities today. So if you're going to do something yesterday, I would encourage you to, it would be very beneficial to question it and challenge it, see if it can improve with the new tools that we have today. Some of our processes that we challenged and made positive impacts were the auto shutdowns, whether using scripts and monitors on GCP tools like VM schedulers. The idea to have an application that would auto shut down was very concerning to some of our users and stakeholders. Some of our applications were used during business hours only. So using VM scheduler, and by utilizing VM scheduler and shutting down these systems from 6 p.m. to 6 a.m., we are saving up to 50% of our compute cost. We also have more advanced ramp down systems that auto shut down if they are idling. If the application is idling, they would ramp down their resources using. And it resumes when the requests are coming in. This was achieved by having the proper tools, real-time monitors, the appropriate labels, but as importantly is by asking, what can we do differently now what can we do differently now and more efficiently than before? My next example is not technical at all. It is a team. Sometimes we need to shift our mindset. My example here is our FinOps team. We didn't have this team in the past, not even the concept at all. As you know, our servers cost in the past were very static. Set it and forget it. But now we have a dedicated team to make sure that we are using our cloud assets efficiently. The FinOps teams works with our cloud technical teams, helping them be more efficient, and by using the real-time monitors and reports, our application team owners and our cloud administrators can make sure that our GCP assets are appropriately sized and utilized. Then, with the proper forecast, our FinOps team can work with Google on the CUDs to reduce our overall cost of our GCP environment. Having FinOps team owning CUDs make managing CUDs much easier instead of having each team manage their own CUDs, which we've done in the past. But since CUDs are account-based, are not application-specific, it is now owned by our FinOps team. So if we commit to using a certain type of VM or a certain type of Kubernetes cluster, it is only limited to this. It's not limited to one application. We can use this committed resource across other applications on the same account. So to summarize this point, my short advice is don't shift and lift only, actually challenge it. And thirdly, I would like to talk about talk to your account manager. You are not the only one facing the challenge you are trying to resolve now. Talking to your account manager is always a good start to see what GCP can help you with and to see what other customers' use cases are. Our account manager set for us many, many roadmap sessions with Google product owners. So these roadmap sessions helped us see if there is a future version that might be the solution for what we're looking to resolve now, or even add as a feature request to the product theme backlog. But one example that really stood out for me was when we were having some technical problems with our SAP systems on GCP. Our Google account manager set a meeting with the Alphabet SAP team that handles similar technical tasks that we were being challenged with. It turned out to be a very, very beneficial session where the Alphabet team shared their knowledge and expertise on how they deal with operational challenges that we were facing. Another example of the account manager's impact on this partnership is where we were introduced to David and Omkar and their teams. GCP was developing a new tool called Workload Manager, or WLM, applicable and beneficial to our SAP systems. Google was seeking conceptual feedback and asked ATB to be part of the design customers, where we worked with the Google team throughout several ideation sessions, and we evaluated several prototypes, and we saw some prototypes, and we were part of the alpha customers to use the tool. And as you saw earlier from Omkar, this tool is now live, and this tool is helping us make sure our SAP builds are following the best practices set by both GCP for the compute engine and SAP Corp for database and application perspectives, helping us provide our users the most efficient and the most utilized systems. And before I wrap up here, as Milo spoke and as David earlier was mentioning, David was talking about multidimensional complexity. He listed 4 items: cost, reliability, secure, and performance. His list reminded me of our cloud vision at ATB Financial, which states, cloud is ATB's secure, reliable, and cost-effective platform for critical, high-value application and workloads. I find it interesting that we share 3 out of the 4 points David listed, and I saw some of the points on Milo's presentation as well. So again, that makes me wonder how many of you are also sharing the same vision or different versions of it. And lastly, thank you, David and Omkar, for this.
All right, thank you, Mo. So let me recap for you all. Managing large fleets of VMs can be challenging. As Omkar highlighted in the beginning, Google Cloud is investing heavily in tools that can help you manage your fleet, no matter where you are on your modernization journey, from fully shifted left to still managing VM by VMs, including tools like VM Manager, OS Inventory, Workload Manager. Second, Milo walked through how CoreLogic has been building automation using tooling like Terraform and GC images and layering on a consistent standardized model to deploy and govern VMs. And then lastly, Mo talked about the partnership, deep partnership that they've been building with Google Cloud from the account teams and how that's enabled them to move quickly in their crawl, walk, run journey to run and move their large workloads on Google Cloud. Thank you all so much for coming. It was a pleasure having you. I hope you all have a great afternoon.